In this video, we will be taking a look at the new data file that you have available in your zip file download. And what you'll do is extract the contents of that zip file into the projects folder that you created on your C drive of your computer. And all I've done was add another file to that project. And here's how we're going to access it. So you go to File, Open Project. You're going to select that same Cortec training folder for the project. And then you're going to go to the T list. And now we're going to go to the second file, to Inlet. And at the very bottom, we have this file. And when you select that, this box pops up and says, oh, you got a different configuration. That's because the test frequencies that I selected for this file when I recorded the data are slightly different than the first tubing example that we looked at. So I'm just going to say yes. Now this data looks pretty nasty, right? That's because it's raw eddy current data. We haven't calibrated it yet. Now, I have included in a previous lesson the instructions to download the data analysis manual from the website, so make sure you do that. And also, there's a little button up here at the top. It says Help. You can turn on tooltips. So if you click on Show Tooltips, every place you go where there's a feature, it'll pop up with like a hint. Now, after you've been using the software for a while, that gets annoying, so you'll probably turn it off. But for now, we can keep it on. Again, this is raw eddy current data, not calibrated yet. And some of you are probably already thinking, why do you have such cool colors up here? Well, you can modify it. You don't have to look at that black and white like you have there. I'm already going to turn off tooltips. You can go to the options menu right here, and you can change the colors. Obviously, I have the background set to black and the data set to green, and you can change them to whatever you like. I have two channels up here for my List right now. Both have 600. But if I click over here in the strip charts and then put my cursor over here and click in the middle and hit the space bar, it balances the data. Now the data still looks way out of whack. That's because my spans are too high. So this little area that's got the 0 here, that's actually my span or gain control. So if I right click on that, it starts to bring that data smaller so I can get it on screen. And I have to bring it quite a bit yet. See how nice that data looks when I span it correctly? Now over here where it says 0 degrees, here I'm going to hold down the Shift button and left click it. That's going to allow me to change the phase of the signal by clicking and dragging in the List view. So there we have our 600 kilohertz. Now again, this is a surface pencil probe. Let me see if I can find where I put it so I can show you what it looks like. This is actually the Z-Tech pencil probe that I used on my Ms. 27. So if you're taking a course for tubing data analysis, you're probably already wondering what's different about tubing compared to surface testing. Well, there are a lot of similarities. The first thing I want to do, because I acquired 4 test frequencies, I want to put up 4 Lissajous screens. So I can do that by hitting Edit Screens right here. And for Lissajous, I can select 4 of them. See that? Now to get the data back in my strip charts, I can just click over here and hit the space bar. Now the expanded strip charts you see down below the Lissajous here, these are the 2 components of the signal in Lissajous. The left-hand side is the Y component and the right-hand side is the X component. If I want to get more of the data, so this is from an EDM cal block. And all I did was I scanned across the surface with that surface probe. If I want to get all 3 signals to show up in the Lissajous, I basically just have to compress the data that's in the expanded strip charts so they're all up here. And I can do that by clicking on this button, points per pixel, I guess that is. Now you can see as I hold down my left button, it brings more data in there. So now when I adjust my span a little bit, and I balance by hit the space bar, now we can select other frequencies up here along the top. So again, this one's out of whack because I haven't adjusted my span and rotation yet. So I'm gonna go to the 0 button and just right click a bunch of times until I can get that data to a more manageable level. Then I'll put the 3rd frequency here, adjust the span, adjust the rotation here, and finally the 4th frequency. It only looks noisy if you got it spanned too hot. Now the goal would be to have probe motion or noise set horizontal. Well, here you don't see much noise at all, do you? So we're just gonna basically, to try to get these things all set the same, I'm gonna put that shallowest, this is an 8/1000 or 8 mil deep EDM surface breaking notch. I'm gonna set that down to like a couple degrees on all the channels. That looks pretty good. Now, when you're doing surface testing, you're usually just trying to find cracks. And oftentimes you probably don't even use more than one test frequency. The big difference with tubing is because you're looking at flaws on the inner surface of the tube and the outer surface of the tube, you have to use a lot more phase analysis or different test frequencies to determine whether the discontinuities are ID initiated or OD initiated. So although you can't see it that great here, there's going to be some phase lag for the deeper notches. The biggest notch you see here is from a 40 mil or 40 thousandths deep surface breaking notch. Now if I go and measure on it, and I'm adjusting these cursors by holding down my right mouse button, and I drag the data down through my window. So when you're scanning a material and you want to replicate your scan direction in the analysis software, the direction of probe travel is going to be from top of the expanded strip chart to the bottom. In other words, the scanning direction would be, and I'm going to hold down my index finger button. I'm just going to click and drag and pull the data down into the window. That's the scanning direction. So there's my 8 mil deep surface breaking notch. There's my 20 mil deep, and there's my 40 mil deep. Now, if I zero in on that indication and just click my left button up here, it's going to measure it. So there it's measuring the back side, 370 to 300. Oh, that's peak to peak. We're looking at the phase angles here. So here we go from 600, 300, 100 kilohertz down to 50. And it looks to me like, let me do that again, 23, 22, 19, 20. So you're not getting a lot of phase rotation here. But as we start looking at tubing examples, you're going to notice a much more profound change in phase readings from the ID to the OD. Now, one thing I want to point out here is surface coils, especially when they're operating in the bridge mode here and you're seeing absolute signals, you're very used to seeing this type of a signal with the absolute probe. But what I'm going to do in the next video is I'm going to use a different type of probe, still with the surface, and it's going to look very similar to the differential signals that are primarily associated with tubing examples. But you can see the data looks the same. And once you see a differential coil data with a surface probe, and then I compare it to a inside bobbin coil probe, you're going to realize, wow, this isn't really that much different. There's just a few more things to learn. So you can have fun playing around with this data. All it is a scan of this block with a surface probe, and you're seeing the 3 notches. and use your user's manual and the tool tips up here, and you can start playing around with manipulating the data with the software. All right, thanks for watching the video.